repeat again. I think probably they can look at my script. They know what happened. Okay, thank you for a reminder. Otherwise, we can't redo it again, is it? All right, guys, have you get the idea of the timeline of your future important dates? CA1, CA2, and CA3. I don't know the date yet. Actually, right now, when will the your final exam be? I'm not so sure. I think they haven't decided yet, probably.
Final exam is on 9th of April. They have decided on Tuesday, 9 a.m. to 11 a.m.
Oh, you have the information already?
When we make enrollment, then they will show us when is
You
the...
mean 9th of April?
Yep, 9th of April, Tuesday.
Okay. So you have to double confirm because I'm not so sure. I have no any information on hand to double check. So I just put a question mark there for you to double check it. These are the information that I'm quite sure. Okay. Because if I make any mistake, some of you maybe unable to attend the final exam, that'll be my fault already. Because I gave the wrong information. Okay, so this is the timeline. I hope you guys bear in mind for this class. Okay. So the next thing that I need to let you know is that your first assignment, second assignment, and the last assignment need to be you need to do it using the MS Word apps. That means you cannot submit a PDF file. Don't submit PDF file to me because I need to mark it. I need to mark your assignment using the comment here. I'll put the comment on your assignment. For example, just like that. I'm the one to mark your assignment usually. I need to put a comment on your assignment. Something like this, correct? Okay, then I give you will get let's say 10 marks here. 10 marks for the correct answer and the correct step. Okay, if you don't submit in the MS Word file, I won't be able to type the comment. Okay, so make sure you do that. And then the next thing that when you submit assignment, most likely you need to zip all the files, right? Most likely you need to zip and submit it. So make sure you follow the format like this. CT11 is a class code, underscore your student ID, and then underscore assignment 1. You can put CA1 is okay. CA1. Okay. And then the last information that is related to the external group we have, WhatsApp group, for you to ask question. Okay, if you have any doubts, you can ask your question there. You can post your question there. Well, I've seen about half of you already, join the group. Probably the rest of the students have to find their way there. All right, so today after the briefing, the morning briefing, we are not going to I'm not going to give you a lecture because this is not a lecturing session. This is supposed to be we call the tutorial time, tutorial session. That means I'm going to give you some example related to your assignment to help you prepare your assignment 1. I'm going to give you some related assignment, and then I'll give you time for you to do it. Okay, you can also attempt your actual assignment if you like. And this is going to be how we spend our time this morning for these 2 hours. So if you have no question, any further question, then we will start our assignment. Do we have any question about the assignment? Some of the detail you need to read, something like you need to type your answer, not handwritten one. Handwritten assignment, not accepted. You also cannot take a Photoshop and then attach to assignment. You need to type it. And That's about all, right? Okay. So your assignments, you can download your assignment from the another portal called the FlexLearn. This is the address, FlexLearn, BOU, my. When you go there, I already logged it in. That's why you won't show the login page. I already logged in this morning. So you have to click on this big icon there. Then you pay attention to the left window here. Okay. Then you need to scroll all the way down. Look for the course assessment. Okay. Then you can download it from here. You also need to attach it together with the declaration form. So this declaration form actually is to declare that there's no plagiarism. You didn't copy from from someone else. It's your own work. Because this is quite important. This is very important because the plagiarism actually is not allowed. In any university, I think. Make sure you do it yourself. Okay. Make sure you do it yourself. Don't copy from someone else, because I'm afraid that they may take the discipline action if they okay. Let me see, I can mute all or something. So far, okay, everyone? Everyone clear about your assignment? Assignment is here actually. So if you're okay, then we're about to begin already. You can download from here, FlexLearn, and some other information like the Unit 1, Unit 2. How about the Unit 1, they place under the course content. So you have to read from the web page. In the past, they prepared the PDF file, but now they converted to the web page. I think make them easier to update the information. Okay, you have to because this is a self-learning kind of a learning experience. You need to actually have the motivation to do it yourself. But today we're not going to go through every one of these. We will just cover some of the basic information, and then I'll give you time for you to try on some example. Okay, so today we're not going to answer all the questions today, because based on my planning, we're going to have another tutorial before the due date. Okay, another tutorial a week before the due date, and then we cover the other 50% on our next tutorial. Okay, so today we're going to cover about 50%. I already prepared here. Okay, Q1, QB, QC. Okay, this is the question that we're going to cover today. Basically, we have how many topics? 1, 2, 3, 4, 5, 6, about 6, 7 topics. Let's start from the something easy, okay? Let's get it started and do something real easy. Let's try the first question, shall we? Let's try the first question. Okay. So when you prepare your answer, you need to do something like this. Let me show you a quick example. You get a blank document file. Make sure you fill up the declaration form and submit together also. Okay, this one you have to do it. Here, make sure you download this form and then fill it up with your personal details, and then attach together with the answer sheet. So this is going to be your answer sheet, right? Okay, what you do is that you just type question 1, and then you type A, and then you start typing your answer here. Okay, type in your answer. Remember to show every step, and then after that you start with a B. So when you need to start a new question, you have to start from a new page. Okay, start from the new page for the new question. Don't join the Q2 under the Q1. Sometimes it might be not easy to find it. All right, let's look at the first question. Q1A, 6 mark. So it's something about the equivalence resistance. So what do we mean by that is that we have many resistance here. We have many resistors with different values. So what is the resistance if you look into terminal A and B? If you look into terminal A, B, what is the total resistance? We call it equivalent resistance. Okay. Usually we call it REQ. Short form REQ. Okay, so I'm not going to show how to do this because this is your assignment. I'm going to give you one example. I want you to give it a try. Okay, give it a try, then you all right. This is an example here. Okay, let me give some guideline first before you start. So what should you do in the first place is that you need to find which branch. This is called the branch. Okay, you need to find which branch is a series connection, which branch is the parallel connection. Parallel. So for example, this is a series, right? Series mean one resistance. We have, let's say we have point 1, or we call node 1 here, node 2, and then we have another resistance. We join together these two resistance. Okay, we join them together. So point 2 refer to this end. Another end here is a point 3. So we have 3 nodes for 2 resistance, right? R1 and R2, let's say. So this is called a series. Parallel concept rather different. For the parallel connection, let's say we have a R1 here with node 1 and node 2. We also have another resistance here. Let's say node 3 and node 4. Parallel connection means that these two nodes join together. So we have basically only 2 nodes, 1 and 2 only. Because 1 and 3 is the same, just a wire only, just a wire. Okay, so basically we can say that we only have 2 nodes. 2 nodes for 2 resistance. Okay, so this must be a parallel connection. Not 1 and not 2. Not 1 and not 2 for R1 and R2. So this node 1 is the common between R1 and R2. This type of connection in engineering we call it common node. So they have a common node shared between R1 and R2. We also have another common node shared between R1 and R2 here. Okay, the wire doesn't carry any resistance. We just ignore this small resistance in the wire. We only look at the main resistance. Usually the wire is resistant. There's a resistance in the wire, but it's negligible. We just ignore it, okay? Because it's too low. It's 0.0 something. It's 0.001 or something. So we just ignore the wire and resistance. So we just join these nodes together. Basically, there are only two nodes for this circuit. This is why we call it parallel. Okay, because they looks like they are side by side each other. This one is joined in the string format. So look like this. This one is the series. This is the parallel. Can you see that? 6 and 3 arrangement looks like a parallel arrangement. 1 and 5 ohm looks like a series. Okay. So for the series, the total resistance is just to you just sum them up. Will do. Okay, really easy. For the parallel, you have to use this formula: 1 over RT. We call the reciprocal value. 1 over RT equal to reciprocal value of R1 plus reciprocal value of R2. Okay, but the simple form that I like to use is something like this. You just multiply the R1 and R2. You multiply R1 and R2 together, and then you divide it by R1 plus R2. So this is the formula that I like to use most of the time. Okay, but this is the main formula. This only apply for two resistors only. So I give you some time now. Now it's 9:30. I give you some time now to try out this. Okay. About, let's say, give you about 5 minutes. 5 minutes time. So this is for your question 1A. Question 1A. Okay. I'll come back 5 minutes later. Okay, let's come back to the first example. All right. First of all, as I say, 1 and 5 are in series. Therefore, you can add it up to form a 6 resistance here. These 3 are parallel. That means you can use this equation to find the equivalent resistance. I think it could be 2 ohm, usually less than the smallest value. So let's look at the answer. So first, the solution show that we look at 6 and 3 ohm first, and then we parallel them using this quick formula. Okay, so we get the 2 ohm for these two, and then the 1 and 5 add up to 6 ohm here. Okay, and then since we have 2 ohm here plus another 2 ohm, they are also in series, so they form a 4 ohm on this branch. 4 ohm. So we have 4 ohm here, 6 ohm here. Okay, can you see that or not in your head? 2 plus 2 ohm and 1 plus 5 ohm, 6 ohm and 4 ohm here. So we redraw the circuit. 2 ohm, 2 ohm, 6 ohm, we redraw it, and then looks like you cannot look at 4 and 8, right? 4 and 8, even though they look something like 4 parallel, but it's hard to tell actually. It's better to look at this branch, these 2 branches. So we have 4 and 6 ohm, both of them in parallel. So we use the parallel equation again to find that the equivalent is 2.4 ohm. So finally, we have a nice simple circuit. They are all in series because we have 3 components. We have 1, 2, 3, 4. We have 4 nodes. 4 nodes for 3 components is a series. Okay, sometimes need to count the nodes for the beginner. For the beginner, sometimes you need to do that. 1, 2, 3, 4. 4 nodes for 3 resistance. Nodes is higher than the resistance, total number of resistance. That's why the is definitely series. So we use the series formula just to sum all the value. And then we get the final one is the 14.4. Okay, so this is the example. So you can use the same approach to try on the question 1A later in the afternoon if you have time. You can use the same approach, same formula to do it. On here, I cannot tell you the answer. I think the first one is easy. We don't want to spend too much time here. Let's go to the next question. The next question, let's say KVL. Okay, KVL. Let's bring out my KVL slide. Okay, let me give you a quick introduction about this another law that I forgot to add in. Another law is called the Ohm's law. Okay, Ohm's law. So what about Ohm's law is you have to it's a relationship between 3 important attributes, 3 important parameters. V, voltage, I, current, and R for resistance. These 3 important parameters, they have this relationship. V on the top, we put the divider here. V on the top, I and R on the bottom. Okay, so in case you want to find the voltage for any branches, any component is equal to I times R. I multiplied by the R to form the voltage. For example, let's say you have a resistance here. Let's say the resistance is a 10 ohm. And then you have current go through it. The current, let's say the current is 2 ampere. So the voltage across this resistance is equal to 2 ampere multiplied by 10 ohm. So we get 20 volt. 20 volt across the resistor. Okay. When we look at the voltage, we usually we are looking at the voltage across the resistance, something like this. Voltage across this node and this node, or the this node 1 and node 2. Node 1 has a voltage 20 volt higher than node 2. So we have a voltage drop also. We have voltage drop. From here we can't tell actually, but we know that the difference between these two nodes is 20 volt. Okay, that means we have the voltage drop across the resistor. Okay, we have a voltage drop. Of course, we have resistance, the voltage will drop, right? Just like if you take the anatomy of the water in the water pipe, when we have resistance in the water pipe, the pressure in the water will drop. Okay, the pressure at this point and the pressure after the resistance is different. Okay, the pressure in the water pipe actually is quite similar to the voltage in the circuit in the wire. It's some kind of the potential energy we call the voltage. The unit is called volt. The unit is volt, and the we have a voltage drop. We have a voltage across. This is how they describe it most of the time. Voltage across the resistance 10 ohm. Voltage drop across the resistance. Okay, and then this is just one only. If you want to find the current is equal to V over R. V at the numerator, R at the denominator. This is a second form. Extract from here, obtain from this this figure, and the last one is R. R is equal to V over I. So this, you can see this is a relationship between these three parameters. These are the relationship between these parameters. Okay, so we have a student to help us to locate the actual slide. Okay, actual slide. Never mind. Let's try the first one. This is Ohm's law. Okay, by the way, this is Ohm's law. And then we also have another one called the KVL, stand for Kirchhoff voltage law. So Kirchhoff voltage law applied to the when we sum in the simple way, when we sum all the voltages in a loop, we sum all the voltages in the loop. Let's say call it the VT total is equal to V1 plus V2 plus all the voltages until Vn. When you sum all the voltages in the loop, you're equal to 0. So what does it mean? What does it mean, KVL? Let me give you a quick one, because I'm not going to spend too much time here. Let me give you a quick example. Usually on a normal circuit, we will need to have a some kind of power. Sometimes it's just a voltage. Let's say we have a 10 volt here, and then we have a polarity positive and minus at this location. At this side we have positive, and then at this side we have a negative. Okay, let's say this voltage connect to two resistance, 1 and 2 here. Okay, let's say it's connect to these two loop. We call the loop actually most of the time. Let's say we have R1 and R2 here. Okay, let's say we have let me pick one good value, 8 ohm and 2 ohm here. So in order to understand the KVL, it's the sum of all the voltages is equal to 0. Okay, this simple equation. So what it means is that usually we have to start from here. Okay, let me show you how I do it. Usually we start from here. Okay, we start from this node, and then we write the equation. We start writing the equation. Minus 10. Okay, minus 10. Minus 10. We start from here. Then we make a turn. So what we see here, let's say we assume the positive is here. We assume negative here. Okay. So we need to sum all the voltages. This is no voltages, right? This is 8 ohm. But remember, when we have resistance in the circuit, we have a voltage drop. So we have something we call the VR1. At this resistor here, we have VR1. How come I cannot write the line here? So VR1 is positive, right? Can you see that? VR1 is positive. When I first come in here, I see the positive first, negative later, right? So that's why I will write positive VR1 voltage, right? Okay, plus another voltage, plus the next voltage, plus the next voltage. So usually we put the positive as here, negative here. This is just an assumption. Okay, we put the positive here, negative here. Because these two components in the circuit is to absorb the power. This is to supply the power. That's why their polarity must be different. You see, because one is to consume, one is to supply. So the VR2 here, positive, negative. We see the positive first, right? So the VR2 equal to, and the sum equal to 0. So this equation we can come up. Okay. Let me tell you another law. I think can be considered a law. It's called the voltage divider law. Voltage division. Voltage division law. This is quite important. You see, we have 10. This 10 need to be split, need to be consumed proportionally, equally within these two resistors. So need to distribute this voltage across these two resistors according to their resistance value. We have 8 ohm here, 2 ohm here. Based on the circuit theory, the more ohm will get more voltage. So since 8 and 2 add together to form a 10, so we can say that the VR1 here actually is 8 over 2 plus 8. This is the voltage division formula. divided by the 10. So 10 watt to be shared by the 8 ohm. Total we have 10 ohm. So if you do the math, the answer is 8, right? 8. Therefore, for VR2 consume the remaining voltage, which is the 2 ohm. 2 volt. You also can be calculated using 2 over 2 plus 8, same formula. Okay. So this is called the voltage division. This is called the KVL. Okay, this is called the KVL. Okay, this KVL. All right. So I give you enough information. Let's try this question. Wait, this got the answer. Let's try this, okay? I think you should know how to do it already, right? Okay, so let's forget about this, okay? Let me go straight to show you the answer. So according to the textbook also show positive and negative here. Okay, and negative at this side, positive on the top. And then he continued to write the KVL around the loop. Okay, just now I forgot to mention this term, the loop. Okay, this is very important. For the KVL, we look at the loop. Let me remind you again. For the KVL, it's about the loop. Okay, just bear in mind. Later you'll know why I type this word to this KVL, because it's really important. So here you can say that you can see it said that go through a loop. So this is a really key word. Okay, this is the key word here. Go through this loop minus 20 plus 2 ohm. Okay, in this case is assume the negative at this end. So minus V2 equal to 0. Okay, minus V2 equal to 0. So it's good that he assumed differently. On my case just now, I assumed the positive on the top, right? I assumed the positive on the top, but in this example, he assumed the negative at the top. Okay, so you can use it as a good comparison. So after you write this KVL equation, we call the KVL equation, and then we are using the substitution method to find the to solve. No, we substitute the this equation into this equation, and then we solve for I equal to 4 ampere. Then we use the Ohm's law to calculate the voltage. Okay, Ohm's law said I equal to V over R, or I equal to what? Let's do it again. V I R. I equal to V over R, right? So V equal to I times R. So V equal to the I 4M times the R. So we get 8 volt. So remember to remember this figure, VIR. It will help you a lot. Okay. Okay, let's come back to that assumption, because some students they confuse about this assumption of negative on the top. Just now I assume the positive on the top, right? In this case, the negative on the top. After you found it, your answer is negative. So what does it tell you? It tells you that the V2 actually positive is on the top. Okay, it tells you that your assumption is wrong, but it's okay. Actually, it's okay. You can assume first. Okay, you can assume the negative value first, But at the end, when you get the answer is a positive, then your assumption is correct. If you assume the negative value, you get a negative, that means your assumption is wrong. Okay, so what it means, V2 equal to minus 12 volt. We also have 12 volt across this resistor, but the polarity is negative. It means the positive should be on the top. Okay, negative is on the bottom. This is what the negative tells you. Here is a positive value, that means your assumption is correct. Positive is actually on this side. Okay, it's correct. So this negative value tells you the assumption is incorrect. But it's okay actually. When you assume the negative here, you get the negative value. When you assume positive here, you get a positive value. Okay, both answers are correct actually. Okay, this is just an assumption only. This is just an assumption. Okay. But this is the previous one. Let's close down this. So let me see. Okay. Now that you know the KVL, let's try it out. No. We're not going to try out this question, right? Let's find the. Okay. So the question here, KVL, use the KVL to solve for the this loop, this first loop and second loop, I2 loop and I1 loop. So this question Q1B is 50 marks. I think you can do that actually. Based on my experience, most students can do this question if you understand the meaning of KVL. Okay. How about you try this question? Oh, wait, this is a KCL. Sorry, I made a mistake. This is a KCL. Okay, let's talk about KCL. Then you can try out this question. Okay. Let me give you a quick example, a quick introduction to KCL. Remember just now I said that the KVL is the loop. Okay. How about KCL? KCL actually is a node. Okay, let's start from the KCL equation. The sum of all the current, let's call it IT. The sum of all the current is equal to current 1 plus current 2 plus all the current until current n is also equal to 0. It looks very similar, right? Looks very similar to the KVL, right? Yeah, very similar to the KVL, right? But remember, I want you to bear in mind this term loop. It ties to KVL. KCL is called a node, right? Node. Let's copy that one over. Let's copy this over. Oh, how come they put everything together? Okay, let's copy this over. So what it means actually something like this. Let's say you have a circuit here. It comes to the junction, and then we make another connection to another resistor, and then this is another branch. So let's say we have these three resistors. They're joined together to form a node. Okay, let's so what we can do is, let's say here is R1. Let's say there's a current flow through R1. Okay, we assume the current flowing through this way. We can make assumption also. But usually the current will flow to the ground. Let's say here is a ground. Ground is 0 volt. It has the lowest potential. Here must be some voltage usually. So the current usually will flow from the high to the low. The current, just like water, it will flow from the high ground to the lower ground, right? So the current flowing down this way. So this we're going to presume the current here also flowing to this node, and then you flowing down here. This is an assumption only, okay? Just assumption. So since this is R1, let's call this I1. Let's say this R2. Let's call this I2. The current I2 flow through the resistance number 2. Let's say this is R3. So we just name it I3. So pay attention to the direction of the current. Remember the keyword is called node. So we look at the node here. I1 go into the node. I3 go into the node. I2 leaving the node. Let's call the node A here. Let's give it a name. I1 go into the node A. I3 go into the node A. I2 leaving the node A. So let's write the equation. I1 plus I3 minus I2 equal to 0. Let's follow this equation. The sum of all the current is equal to 0. The sum of all the current entering a node or leaving a node is equal to 0. This is a definition. Okay, let me repeat. The sum of all the currents 1, 2, 3 is equal to 0. So if you ask why I2 is negative, because I2 is leaving. I1 and I3 they are entering, so they have a different polarity, because the behavior I1 I3 is into, I2 is leaving. Okay, so they should have an opposite sign. Or you can rewrite it. Some engineer, they just rewrite it like this: I1 plus I3 is equal to I2. So this give you another indication that only one current leaving the node A. That means this current is a sum of these two current. Two current go in, one current leaving. So this current must be the sum of these two. Okay. Of course, you can have many branches. Then you can continue to write the equation. Okay, let's try. I hope you understand this simple introduction, KCL, about the KCL. Let's try this question. So this look quite funny, right? This look quite abnormal. Suddenly we have something like 0.5 IO. IO is here. Okay, so this is something we call the dependent current. Current source depend on this current. This is a current source actually. You can say this is a current source. It depends on this current. This current source is half of this current here. Whatever current flow through the 4 ohm, we have a current source coming from this, going up here. Okay. Current is called the current control current source. In the engineering, the full name is called the current control current source. This is a current source with an arrow. This is also current source, okay? But this current source is depend on this current, so it's called the current control, current source. This is just a current source only. This is some kind of source can provide the current, right? Can supply the current. But this is just a normal current source. This current source depends on this current. This current is come from this actually. So this current will create another current source here. Actually, in some electronic circuit, we can find the behavior like this. For example, the amplifier, transistor circuit. When we have a current flowing through at one branch, we will create another current at another branch. Okay. For example, here we have current flowing through this box. Okay, let's say it's called the I1. On the other side of the circuit, we also will have the current flowing through another component. Sometimes this is I1 times 100. When we supply the current at this circuit, we will get another amplification, 100 times current flowing through another circuit. This is called amplifier, right? So this is something similar to this current control current source. That means this current source is controlled by this current. Okay, the main current is here, but here we have a an amplification of 100 times more current generated from the power source here, but the one to control this current is this current. This current control the current here. So for example, let's say you have 1 amp here, you will get 100 amp here. Okay, because this power supply will supply 100 amp. Whenever you supply 1 amp here, you will supply 100 times. Something like this. When we have current here will supply half only. Okay, so this current control current source. You can Google it to find more information. Okay, I want you to try to find this I/O. What is the value of the I/O? This is KCL. Okay, I give you some time to think about this. Okay.
So you talk about the node, right, for KCL. Can you explain more what is the node?
A node is the a junction, something like a junction. Let's say you have this is a called node, right? This is called a node. This is called a branch, like the tree branch. A is called a node. A node is where you have a current flowing through, the current flowing into or current flowing out. It's called a node. It's something like a point in a circuit. At this node, the voltage is fixed. And then we have another node with the voltage also. It's called a node. So basically, we have voltage node. We have the current is a branch. Okay, branch current. And we also sometimes we say that we have the beside these two words, we also have something we call loop. Loop actually apply to the node. They are not similar, sorry. They are somehow related. They are somehow related to each other. For the branch, usually we have the node. Sorry, loop and what is that? The other name already?
Mesh.
Mesh. Let me see.
Is it mesh?
Loop. Branch. Loop. Yeah, something like mesh. Something. Max is equal to loop. Branch, we have a node. Branch is a node. Sometimes we have this thing. They are related to this. I don't know how to define the relationship. Okay, but they somehow they are related. For example, let me give one quick example. Okay. Let's say you have a voltage here, resistance, right? Another resistance. Over here, another resistance. So first we have to identify the node. So this is a node. So usually we just name them V1. You can use N1, but V1 is better because this is a voltage node. We won't call it voltage branch, we call it voltage node. This is one of the voltage node here. Another one is here, V2. Another one is V3. Since V3 and V4 is the same, right? So we just don't need another one here because they are the same here. There's just wire. Right? So here also V3. So here's different voltages. So it's called a V4. So the voltage will be different across each node. The voltage at this end, of course, will be higher than voltage at this end because this is nearer to the power supply. When the voltage go through this one, it will drop. Something like this. Something like you have 10 volt to start. You have 10 volt, okay, to start with. And then you connect through a first resistor. So at this end, if you call the V1 of course is 10 volt. When you go through the resistor 1, the voltage will drop. So we have another voltage here. We call the node V2 node. And then if you connect another resistor, you'll drop further. The voltage will drop further. The voltage is different. That's why we call it a V3. You will drop further. If you connect another one, this is called the voltage divider actually. You will drop further also, but at the end, since it's ground already, ground means the zero potential, so it's 0 volt. So the 10 volt going to be shared among these three resistors. So let's pick a good number. Let's say you have 1 ohm here. Let's say you have 2 ohm here, and then here let's say you have 7 ohm. Let's pick a good number so that we get a good division. We can get a round number. So the 10 volt to be shared among 10 ohm in total, right? In series 10 ohm. 1 ohm take the smallest portion. So 10 volt is here. After the 1 ohm, you will drop one volt only. So V2 is equal to 9 volt here. 9 volt drop another 2 volt. Since they are proportional, right? 1 volt, 2 volt, 7 ohm add together to 10, add up to 10. So 2 ohm of course will drop another 2 volt. So we have 7 volt here. So the 7 volt across the last resistance. So we have the V3. V3 can be shown like this from this node to this node. V2 is from V2 is here from this node to this node across resistor. So V1 can be seen like this from this node to this node, from this to this. The voltage across or the voltage drop. So just now I mentioned about these two terms. They use it frequently. Voltage drop and voltage across. You can use these terms to describe the circuit. Voltage drop, voltage across. This is what they do. Another one is called the voltage node here, node. So the voltage here, let's say this is R2, right? Let's say this is R2. So we must have a voltage drop across this resistor. Let's call it VR2. Actually, VR2 is equal to V2 minus V3. Because it's a different, the voltage drop between these two nodes. We assume the V2 is higher. We assume the V2 is higher because the V2 near to the power supply. The voltage will drop further if it's away from power supply, right? Like this, voltage will drop further. Okay. At least the voltage here is higher than the voltage here. The voltage here is higher than the voltage here. You see, when you go down the string, the voltage will continue to drop. But this 7 volt, the 7 volt across this resistor is a voltage across. It's not the it's not means that doesn't mean the voltage 7 volt at every point here. It's not what it means. What it means is that the voltage at this node we have a difference of 7 volt. Or you can say the voltage at this node is 7 volt. Okay. All right. Let's look at the time we have. We do not have time to cover all. Let's look at answer now. So first, the KCL is about sum of all the current, right? So we have one current going up, and then you make a turn. This current going up also, of course, you will make a turn. So this current is going down. So let's use the equation. The sum of all the current is equal to 0. 0.5. Let me use my own way to write the equation. 0.5 IO is going into the node A. Another one going into the node A is a 3M. So plus 3M. This one is going out, right? Going out. So it's minus IO equal to 0. Sum of all the current leaving or entering a node is equal to 0. Okay, let's write down one more time to remind ourselves. Sum of all the current, going into or leaving a node is equal to 0. Sum of all the current going into or leaving the node is going to 0. This current plus this current plus this current. When I say plus, because it's a minus sign here, actually it's a plus. Actually the real form should be like this. 0.5 IO going into plus this one going into plus 3A plus sum of all the current, but this one is going out. Going out is a negative value, so plus negative IO equal to 0. Sometimes I just write real quick. I just use negative straight away. But the real form should be like this. Based on the definition, sum of all the current right equal to 0. Since this current is going opposite, this is why I use the opposite here. Okay, this is the real form. This is a simplified version really. After you have this equation, since we have only one unknown, IO, we can reduce this equation to IO equal to 6A. When IO equal to 6A, the V out is equal to, using the Ohm's law, V equal to IR. V equal to IR. So V equal to the I times the R. R is a 4 ohm. So we have the 24 volt across this resistor. We have the 24 volt from here to here across the register. Okay, so this is the KCL, Kirchhoff current law. Okay, so this is the name of the scientist, Kirchhoff's current law. Okay, Kirchhoff's current law. One more time, Kirchhoff's current law is the sum of all the current into a node. Okay, let's highlight this keyword again. Node. If you compare to the KVL, it's a loop. It's a loop. Can you see the difference? This one is in the loop. Okay. This summary. KVL. Just use 1 minute to do that. KVL is something like this. These are not. KVL is sum in the loop. Sum of all the voltages in the loop. V1, V2. Whereas KCL is node. KCL is this node. I1, I2, I3. Okay, is the node. Sum of all the current into this or leaving the node. This is sum of the voltage in a loop. So they are quite different usually. That's why I keep mentioning to you, one is a loop, one is a node. This is a node, right? This is a node. Node. Okay, just bear in mind that. So we have how many questions? We have how many questions related to the KVL, KCL? We have a 1B, 1B, and this one we'll do it next time. This is a theorem we'll do it next time. So we have another Kirchhoff law. So this Kirchhoff's law reply to KCL, KVL both, and Ohm's law. So there's typo here. There should be a Ohm's law here. Okay. Never mind. Okay. We have typo. Okay, you need to insert this law here. Law. The typo. Oh, I make it worse. Never mind. So this is a typo. Huh? This is a PDF file. Okay, this is a typo here. Ohm's law. So this circuit looks rather simple, right? I think you can score this one. Okay, you can score this. And okay, this is the next one. We're going to use this one, nodal analysis and mesh analysis. Okay, another question is here. 3C asks you to explain the KCL and Ohm's law. Actually, today with AI tools, I think you can easily get answer, right? It's better to use both figures, sentences, and the equation to describe. Let me show you how to get the full marks. If you didn't do it, you still can get quite high marks, but not the full marks. Okay. Let's say Q3 C1. Okay. Okay, first, you use the words to define the KCL is sum of something something something, right? So these are words, and then you continue to use the figure to illustrate the concept. Use a figure. I1, I2, I3. So we have I1 plus I2 plus negative I3. Again, I3 is opposite. I3 is going out. This one go. Hey, wait. I2 also going out, right? I2 going out. Only I1 going into the node A. So this one also negative. Equal to 0. Okay. So this is the main equation. You can also give an example. If I1 equal to 1 ampere, I2 equal to let me see here. 0.5. Okay. So I1 equal to I2 plus I3. Let's say this is unknown, okay? Let's say this is unknown. This is unknown. Therefore, I3 equal to I1 minus I2. I1 is 1A minus 0.5. I3 is 0.5. You can give example. So with the definition, with the figure, with the equation, with the general equation, I forgot to write the general equation. Sum of current N, okay, is equal to I1 plus I2 plus until the IN is equal to 0. This is the general equation. So you have the sentences, you have the sentence, you have the figure, you have equation. Check. You have an example. You have 4 to describe the KCL. Of course, you can get full credit, right? So if you give me the one sentence like this, it's hard to give you the full credit. For example, because the answer is right at your fingertips only. You just need to type, and then you will get the answer. But be sure you type the. You see how people describe it? Of course, this is an image. All these are images, right? So images, you can't find any text, right? But at least here you can find some text here. Current entering equal current leaving. How about this? The algebraic sum of the current entering any node in the circuit is equal to 0. Okay, this is definition. Another definition is here. This is not a very comprehensive one. Let's look at this. Current entering the node equal to current leaving the node. So there are so many ways you can describe it. Of course, we have a better way, right? Some better way. So, for example, if I using words, I using the words, I using the figure, I using the example, I using the general equation form. Of course, I can get full credit, right? Yeah, that's how you can score the full credit, by doing as many as you can. Okay, let me read the message. All right. So I hope you guys are clear about the how to get the maximum credit. Okay. Or if somebody want to join it, I need to grant them the access. I think it's too late, right? I think they are not belong to my student because all of you, all the student name are already added as the member. I already added you all as a member. Where is it? Oh, here, okay. I already added you all as a member. With 40 members here. So they are, I think they are external. They are not the student enrolled in this class. Somehow they find their way here. Probably they belong to another batch or another batch of students. But it's okay for them to join. It doesn't matter. All right, so we have the KCL. So KCL, we have, this is a bit tricky actually. Wait, this is not KCL, right? This is nodal analysis, okay? We need to do this right away. How about question 4? Question 4, we have another column mass analysis, and this one is the maximum power transfer. This is the maximum power transfer theorem. We'll cover it in the next tutorial. Now we're down to only 2 analyses we need to cover. Here's the KCL, but this is just explain it. You need to explain it. So this is almost like a free marks to you. You can use the AI here. If you don't know AI, I think you should know it by now. The AI will give you the AI is like your co-pilot, they call it, the co-pilot. They are explain everything to you in a really detailed form. Okay. So if you still don't understand, you can keep on asking to simplify it or something. So you have to make use of this tool in a good way. Don't try to use it to you know, you need to learn something from the AI also, not to copy and paste only. See, the AI give you some example. About 90% is correct, I think. Not 100% correct. Sometimes I find a mistake also. Okay, if you don't know, you can use AI. But right now we need to cover the mass analysis and the nodal analysis for today's tutorial. All right, let's do that right now. Later I'll share all the slides with you. Okay. Let's do that. Do it right now. The nodal analysis. Q3B and Q4A, I already let you know. Q3A, Q4, Q4A, Q3B, Q4A. Okay, let's look at the nodal analysis. So we have the circuit, looks quite familiar. We have the 2 power supply, 2 power source, 2 voltage sources at each end. We have 3 resistors in the center. What nodal analysis means is that it's using the node. Okay, it comes from the word node. We talked about just now, node. So what it means is node A usually, node A. B not quite, because B looks like ground to me. We have the negative end here, negative end, and then this is a wire. This is a wire. Looks like B is the lowest point. I can tell with confidence that this must be 0 watt here. 0 watt and not B. Okay, let's learn about what is nodal analysis talking about. So for the nodal analysis, we need to look at the loop. So the keyword loop is tied to a nodal analysis. Okay. So first we need to draw 2 loops. one at the left hand side, another one at the right hand side. After we draw these two loops, we use a KVL. Well, this is quite complicated, right? First, we define the loop. We assume a loop here, assume another loop, current loop here, and then we use a KVL to write the equation. So KVL is the sum of the voltages in the loop. Remember? Remember, just now I linked the KVL to the loop. Sum of all the voltages in a loop. 20 volt is the power source. You will power these two. So if you look at this loop, minus 20 plus the 5I1. Because this I1, right? We assume it's I1. And then plus 10I3. I3 passing through the 10 ohm. So this already rewritten in different form. Basically, the initial KVL is the sum of the voltages, right? Let me show you. It starts from the minus sign here. So minus 20 plus because this is the volt, right? So we need to convert this one to the voltage across 5 volt, 5 ohm is a voltage equal to, let me remind you again, voltage equal to IR, I times R. So equal to the current I times the R, 5I1. I1 plus I3 times this one, because I3 times I current times R, right? I3 times the 10 ohm or 10I3, okay? 10I3 looks logical. I3 10 doesn't look logical to me. So this is the first equation. If you rearrange it, it becomes 20 equal to sum of all the voltages equal to 0, right? KVL. And then we rearrange it, become like this. Okay, at the end we have 3 equations. This is the tricky parts, okay? This is the tricky parts. At the end, we have 3 equations, 1, 2, 3, for 3 unknowns, I1, I2, and I3. So KCL, equation number 3, actually not using the KVL, right? Using KCL. KCL is sum of the current at node A, current I going into current I3, I2 going out, leaving the node. So I1 is equal to I2 plus I3. So we have 3 equations for 3 unknowns. Okay, 3 equations for 3 unknowns. Actually, can be solved. I mean, these 3 unknowns can be solved with 3 equations using the simultaneous equation we learned in the secondary school. So actually, what you can do is you can go to the symbol lab. If you forget about this simultaneous equation, how to solve the simultaneous equations, you can go to the symbol lab website. It's a tools. Okay, you come to this website. You want to solve for simultaneous equation, right? Let's pick a function or something. Okay, let's put a problem here. Okay, because we're not going to use I1, I2, and I3, right? It's a quite a hassle to write I1, I2, I3, right? So we replace the I1, I2, I3 with the character X, Y, Z. X being the I1, Y being the I2, and Z being the I3. Okay, we substitute them. So we put these 3 equations into the symbol lab, 3 equations. 5I1 10I2, 10I3, 2I1, 2I2, and so on, right? So the XYZ represent the I1, I2, I3. So we put them in one line, and then we separate by the comma. You can see the comma. And then if you ask to go, it will solve for the unknown for you. Of course, we can do it by hand, right? But the software will show you how to obtain the final value using the substitution method. Using this method to solve by substitution. If you want to solve by another 3 methods, you need to pay, I think. Let's say I want to solve by elimination. Okay, it's solved also for me. The answer is the same, doesn't matter. At the end, the answer is still the same. Let me try to solve by Cramer's rule. Cramer's rule is quite a famous one. It looks like now it's free already. Because in the past, when I use different methods, you ask me to pay and subscribe to the service. Now it's giving you all for free. Let's try the last one, Gaussian elimination. I don't know if this is a time limited offer or something. So if you've already forget about all this method, you can do a quick review yourself. But to me, that usually I will use the substitution method in exam time. Let's talk about your exam time. For your exam, you need to do it within the 2 hours time, within the 2 hours time frame. It's considered open book. Open book, you can use any tools you have at your disposal. Within these 2 hours, you need to show us the steps and the answer, all typed into the MS Word file. So no, sorry. You don't need to type into the MS Word file for the final exam. You just write it down on a piece of paper, and then you just scan it and copy and paste the graphic file into the MS Word file. Because we have 2 hours only, don't spend your time on typing. You just use all your time to solve the problem, and then use the easiest way to represent your answer in MS Word file by copy and paste or by whatever means to show your calculation, your steps, your working steps leading to the answer. Okay, to show us that. Because final exam is 2 hours time, unlike your assignments, you have many days for you to prepare. Okay, now I show you how to use the Cyborg to solve for the simultaneous equation, to solve for these 3 equations for 3 unknowns. At the end, you should be able to find that the current. You should be able to get the current for each unknown, 1M and 2M. Okay, you can use the same methods. You can use the same method for this question. Okay, but let me give you some guideline here also. Wait a minute, this is a nodal, nodal. Nodal is the sum of all the currents. Okay, current one here. Actually, here's a clue already. Here give you a clue. You can say here's a starting point. Not here. Okay, see here, this current flowing through the 2K ohm, the currents must be come from this power supply, right? And this power supply only need to handle one resistor only. So you know what I mean? From here, you can quickly determine the current already. Then you have a first current. So I1 actually is going this way, and then you're going up into this node. Okay, I1 is going into this node. I0 is going down, is leaving this node. Let me show you the other places. Let me copy this. Okay, let me show you how to handle this question. Because we need to use the nodal, remember? We need to use the nodal analysis. Of course, you can use the Ohm's law together also. Ohm's law and KCL, KVL. But you cannot use mesh analysis. You have to use nodal analysis. Okay. So nodal analysis means that the current here, I1. So we have I1 going up because the loop is going like this, right? So this I0 is going down. So we presume I0 is here. We have the 12 ampere going to this node. Let's call it this node A, okay, shall we? Let's call it node A and node B. So this current going to the node A from this branch is 12 milliampere. Another current is going down is I call the I0, okay, to be determined. Another current here we are not so sure whether it's going up or going this way, right? It's hard to tell actually, but you can make assumption. You can assume the current here is going this way. Okay, let's give it a I2 or something. I2 go this way. You can also assume the current is going down here. I3. Okay. So let's say at the end, I3 just hypothetically, let's say you find the answer here is negative 2n, for example, hypothetically, okay. Let's say you find the I3 to be negative 2. That means your assumption is wrong because it's negative. That means the I3 should be going up. If it's going up, then I3 is equal to 2m. Okay. So the sign actually tell you something actually. If you assume the current going down, you get the negative sign. It tells you that the real I3 should be going up. If it's going up, become negative, positive. Okay, so the sign only tells the direction only. What we want is the value. What we want is the number 2. Okay, the sign actually tells you your assumption is wrong. The actual one should be going the other way, not this way. Okay, but when doing the analysis, we will first start from assumption first, right? We need to assume the current going down first because we don't know whether it's going up or going down. We need to make some assumption first. That's why they call assume the current is I3 going down. So when you have unless the question clearly tells you the current is going down, then you need to follow. Okay, like this, I1 is going down, I0 is going down. I mean, in the figure is going down. Actually, it's leaving node A. Okay, so you need to follow. For those current that didn't show any direction, you just need to assume first. Okay, don't afraid to assume. When you assume, you get a negative sign. That means your assumption is wrong. It's going the other direction. But the number here, 2 ampere, the absolute number is still correct. Only the sign different only. Okay. So because some students they keep asking the negative sign, positive sign. I told them that this sign actually tells the direction only. What we want is the absolute number most of the time. Okay, we want the absolute number. So this is a nodal analysis. This analysis applied to this question. Q3B. Another question we're going to cover next is called the mesh analysis. Where is it? Okay, where? Here. Mesh analysis. Q4A. Mesh analysis. Okay, let's look at mesh analysis right away. Okay, wait a minute. It's here already. It's here already. Okay, so here I'm using a nodal analysis to solve the same circuit use the same circuit here. First, I'm using the nodal analysis, okay, at node A. At node A, nodal analysis. And then the same circuit, I'm using the mesh analysis. So the mesh analysis is using the KVL. You can tell the mesh analysis that if you compare to the previous method, we have I2 minus I1, I2 minus I1, right? It's quite different, right? Even though it's also KVL, if you compare to the previous one, also KVL, right? But this time, using the mesh analysis, you can see it looked rather different, right? 10 I1 minus I2. Okay, let's see how to get this equation. So for the mesh analysis, of course, we need to draw the mesh, which is a loop. Okay, not the node, the node. The loop, sorry, the loop, or we call it mesh analysis, right? Mesh. But most people just refer this one as a loop, Okay, so 20, we need to sum all the voltages. 20 plus this one is there's only one way, right? The voltages is the resistance times the current straight away. But for the 10 ohm, we have two meshes here. 10 ohm is between I1 and I2. Can you see that? 10 ohm is right at the center between I1 and I2 mesh. Within these two meshes, within these two loops. That's why 10 ohm is, because we assume the 10 ohm positive on the top, So when the current flowing down from the top is called positive value. When the current going from the bottom to the top is called negative, right? So I2 is negative. I2 is negative because I2 is going from the bottom to the top. If you go around like this, you go around, you follow it, you follow the arrow, you go around, you can see the current is going into the negative polarity and then going out from the positive. But we look at the negative value first, right? So the current I2, when you go through the 10 ohm, you see the negative sign first. That's why we have negative I2. I1 going to the 10 ohm because you see the positive sign first. That's why we have a positive here. So this is called the mesh analysis. Okay. If you compare to the nodal analysis, it's quite different, right? Nodal analysis, even though it's still using the KVL, KCL, but the way how it looks, it's quite different, right? We have these two meshes here. In some form, they are quite similar. Here we also have 5I1. Here we also have 5I1. But this method, we need to draw two loops. This method we don't need. Even though we still show the loop 1, loop 2, right? So it's quite contradict each other. So my statement say we don't need to draw the loops, right? But for the mesh analysis, you need to draw the loops. Okay. Yes.
So I think for the loop is for KVL, but it's for Kirchhoff voltage law is for loop and mesh, right?
Yeah, this is a mesh.
Yeah.
The arrow. This is quite confusing actually. You see, KVL, in order to sum all the voltages, right? It's called the loop voltage, right? I don't know. We are not talking about KVL right now. We are talking about the difference between the nodal and the mesh. This is the mesh.
Yeah,
okay?
yeah. So in short, nodal analysis is applied for Kirchhoff current law, which is KCL, and KVL is for loop and mesh, right?
We both can use the KVL and KCL. Both. But mesh analysis, we need to this one is going on this loop only. Okay, one more time, sorry. For the nodal analysis, we only look at the node, and then we look at this loop only. For KCL, for mesh analysis, we look at the loop at both ends. Okay. Let's see. Let's say you go to Google. Oh, come on. It won't allow me to click. Okay, let's let. You see the mesh analysis. You look at most of the search result you can find. You always drawing the mesh loop. Mesh, right? So the R2 is between mesh 1 and mesh 3. R2 here is between the mesh 1 and mesh 2, right? R2 is between the, you can call the loop 1 also and loop 2, right? But if you talk about the nodal analysis, we also draw the loop. But this loop is rather different. This loop is a loop in this one only. We don't look at the next one. Okay, we look at the loop. Hey, wait a minute. This is the nodal analysis, right? So nodal analysis look at this one, and okay. I think I confused already.
Yeah, sir. I see you're confusing us. That's why I asking you
okay.
Nodal analysis and node analysis.
Okay. So this one is also the mesh. Sorry, also not nodal. What the nodal analysis means is that let's take for example. I think this example is wrong already. So this one is still the nodal analysis. Okay. This one is still nodal analysis, but the way how we solve now we introduce 10 I1 minus I2. Here we didn't using I1 minus I2, right? But what the nodal analysis mean? Where is it? Is you will see something like this. V1 minus something equal to 1. Okay, that means when you go to the circuit, you need to define the V1 here and V2 here. Let me bring out this circuit and show it elsewhere. So let's clarify the nodal analysis because nodal analysis is somewhat different. First, nodal analysis must look at the nodes first, right? Let's do it properly. Nodal analysis. So we must define the node first. Let's call V1 and V2. So the voltage between the 5 ohm, okay, the voltage for this 5 ohm is actually V1 minus V2, right? Okay. Because the voltage here must be the voltage between the voltage of this 5 ohm must be the difference between these two, right? Okay. And then the current of this 5 ohm is a V over R, right? V over R. So V is V1 minus V2. R is the 5 ohm, right? Okay. So here we can use a KVL to sum of all the voltages in this loop. So let's call this I1, this I2. Okay. But we define the voltage node here. So another voltage node here, V3. So V3 is directly can read from here is 8 volt. Okay, so the sum of all the voltages in this loop for the 2 ohm is a V3 minus V2. And we use the sum of all the current, right? Sum of the current, this current plus this current. Okay. Just when you come to the nodal analysis, you have this node, voltage node, voltage node, voltage node, voltage node, right? So this is called the nodal analysis. But we're still using the sum of all the voltages using the KVL. Just the way how we use it is we define the voltage node here. Another example is here, voltage node here, and voltage node here. Okay, wait a minute. Okay, another example is here. We define the voltage node A, voltage node B. B is also here. Voltage node C, not D. Okay, and then we sum of all the voltages using the KVL. It's just how we represent the current. Actually, is the current. Okay, so this voltage over the resistance, right? 1K. So this is the current. Voltage over the resistance is current. So in short, because this is quite a messy already. Let's but since we don't have time, I don't think I can come up with another good example. I think there are plenty of examples on the net. You can go through it. Those are nodal analysis. I think most of them are you can trust most of the content here, because this is quite a basic theory. For the nodal analysis, okay, nodal analysis example, right? You need to use sum of all the current, but the current represent in the voltage node here. Okay, unlike the my example here, I didn't define the voltage node, right? There's no voltage node. It's all mass current. So this is called a mass equation, right? This is called a mass analysis. Let's change this one. Mass. Okay. So I do not have the nodal here. Yeah, for the nodal analysis, you need to find it from the net, for example. So all the analysis here is I think is a mass analysis. Cannot call the nodal analysis. Even though the methods here is somewhat different, right? Somewhat different, but I still consider the mass analysis. For the nodal analysis, okay, this example here. And node 1, the current, sum of all the current equal to 0. So what it means is that, let me give you a quick guideline here. Okay. For the nodal analysis, first you need to find a node. You need to find a node here. Let's say you find the node A. So we have this current I1, this current I3, and this current I2, right? Okay, first we write down the sum of current using the KCL. With KCL, 1 in, 2 out, right? 1 in, 1 going into, 2 going out from the nodes. So we have I1 equal to I2 plus I3, right? So straight from the figure we can tell. Now we convert this one to the node. Convert this one to nodal analysis. Okay, I1 is equal to what? I1 is equal to the because the I1 here flowing through the 5 ohm, I1 also flowing through the 20 ohm, right? So it's the same current here. I1 is the same current in this loop. I1 is always same, whether I1 is going through a 5 ohm, 10 ohm, or 20 volt. I1 is the same in this loop. So we can just pick only one here. I1 equal to, let's define this voltage here, V1. Let's define this one, V2. I1 equal to V1 minus V2 over the 5. So this one is the Ohm's law. So we're using a KCL, we're using the Ohm's law. Okay, but with the best method is nodal equal to I2. So I2, we can take this component here or this component, but it's okay to take this one. So let's define this one V3. V3 is equal to 8 volt, right? So I2 is equal to V2 minus V3 over 2 plus I3 is I3, we only have one node, right? Only have one V2, and this one is 0, right? Here's 0 because the negative here. So 0 volt here. So I2 is actually sorry, I3. I3 is actually V2 minus 0 over 10 ohm. So this is called the nodal analysis. How can we tell this is nodal analysis? Because we have all the voltage different, and then we use the we base on one node only, node A. We base on one node. That's why it's called the nodal analysis. It's really, they are quite similar in some way. They are quite similar. You see, this one we look at the loop. We look at the loop, right? This one we look at the node A only. Node A only. Okay. Therefore, you need to find out your unknown going to be voltages. All these voltages going to be your unknown. Unlike the mass equation, the unknown is the current, right? Nodal analysis, the unknown is the voltages. You can tell from the other example. So all the unknown here is the voltages. Of course, you also can have the unknown for the current, because the current I1, this is actually a current I1, right? This whole thing here is a current I1. So this is going to be our unknown. V1 also unknown, V2 unknown, V3 we know is 8 volt. Okay. All right, I'm going to move to the next topic. This nodal analysis, I think you just need to, if you still don't understand, you have to rely on the online material to learn more about this nodal analysis. Okay, let's cover the last topic for today, which is the Y and the delta network, or Y and delta connection. So you can see, if you look closely on the outside parameter, here, you can see the value, right? 3 ohm, 10 ohm, and 30 ohm. And then on the inner one, on the inner resistance, there's unknown, right? R1, R2, R3. So what it means is that we can convert this outside parameter one, ABC, RABC, into the inner circuit. So one looks like the delta, the other one looks like the Y. Let's bring my one looks like the Y connection. Another one looks like the delta, but some people just call it Y. See this word Y. Actually, it looks like Y. Okay, so you look at my example here. To convert from the delta to Y, you can see this is Y, right? From delta to Y. The first value here, R1. Let me draw the Y here. And let me go to R1 here. Okay, so R1 is here. You look at the R1. If you want to convert the delta to the Y connection, the R1, the adjacent of R1 is 25 and 10. Okay, one more time. The resistance adjacent to the R1, the imaginary value R1. The adjacent value is the RB and RC. So what you do is you put RB and RC product on the top. At the bottom, you just sum all the resistance sum all the resistance in the delta ABC. Then you can calculate R1. So eventually, you will convert from delta into the Y. Okay. So what R1 calculated value is 5 ohm. Okay. So this is the formula. This is the opposite. This is the opposite to convert from delta from Y to delta. Okay, let's look at this method. This is from Y to delta. Let's look at the A. The A value, RA, the equation is R1, R2, R2, R3, R3, R1 is all the possible combination actually. There's no R1, R1, right? There's no R2, R2, R3, R3, right? So this all the combination of the of different value, R1, R2, R2, R3, R3, R1. There's no R1, R3, right? R3, R1 is the R1, R3. Okay, so with all the possible combination, excluding the R1, R1, R2, R2, or this, right? All this combination or the mix or the pair value, and then divided by R1. So R1 is really important, right? R1 can determine the A. So R1 is here. R1 actually is opposite of A. R1 actually is opposite of A. Okay. So for the RB, the opposite is R2. If you look from RB, you look towards this direction, you can see R2. So R2 put at the denominator. On the top is the same. On the top, numerator is always all the mix, all the pair, different pair. R1, R2, R2, R3, R3, R1, right? So this equation is from Y to delta. The previous one is from delta to Y. Okay, let's look at our question again. Our question is, this thing just get into the way. Let me wait for it to disappear. Wait to do it. Anyway, oh, it's right here, sorry, right here. So this one is what? It tells you already convert typo, convert delta to Y. So the outside is delta with the value. Inner one is the Y connection. Convert from delta to Y. Actually, this circuit, all the line is in solid line is a bit incorrect. Actually, at the center here should be the dotted line to represent from delta to Y, just like the example here. We have the dotted line. We have the solid line to represent convert from. This is also same, also using solid line. But I personally prefer the solid one is the current one. Okay, to convert from this delta, the current one, to the Y. I prefer to draw the Y at the center using the dotted line. So it's all solid line. It's a bit confusing, you see. If you don't know about this topic, you don't know how to start from here. Actually, what he wants you to do is that he has delta connection. He wants you to convert to Y connection. Okay. Actually, I can give you a hint for the next assignment. This one related to the next assignment. In your next assignment, you will encounter one circuit like this. Hold on, yeah. What happened to my? Okay, let me use another platform. Okay, let's use this one. In your next assignment, assignment 2, you will encounter a circuit like this. Okay. Like this. And this is your REQ. Back to our first topic of today. What is the total value of this network, right? So if you look closely at the center here is a Y. At the center here is a Y. Can you see that now? At the center here is a Y. 1, 2, another branch here. Y, right? Even though it looks like a T to me, right? But we consider it's a Y. Actually, we can convert this circuit. We can convert this circuit from the Y to delta. So if you convert to delta, it looks like this. The top remain untouched. This one become delta. And then another delta here, another delta here. At least these two are parallel, right? These two are parallel, and then they are also in series. Otherwise, you're not sure whether this one is parallel, this one parallel, this one, or this one, these three are in series. You cannot tell for sure. But if after you convert the Y to delta, this yellow color one, you convert to the delta. Can you tell the difference? Now it become delta already. This Y now become delta. The top remain untouched. These two will become parallel. And after you convert this one, actually it reduced to the top. And this one, right? And this is your output here, REQ. So what you do is, these two is a series, then parallel with the last one. Then you can solve a problem. Otherwise, when you look REQ into this direction, if these two parallel or series, you can tell. These two parallel series, you can tell. You can't move a step. You cannot continue like this. You see, after you convert, then you can continue. Right? After you convert from the Y to delta, you can continue. This is a preparation for your next assignment. Actually, your coming next assignment, you need to have this knowledge to solve the analyze the circuit. You need to know this. Okay, guys. I think today we are studying over the time. So you go home. Sorry, you're already at home, right? Okay. So I want you to for this session. After this session, I want you to try all these questions. Let me point them out to you. I want you to try, not to try, to answer it. Okay. I want you to try answer Q1A, Q1B, Q1C. Okay. Basically, all the question 1. Skip question 2. We leave it to the next tutorial. Question 3, you can do it. Question 3 is just a Kirchhoff and Ohm's law. B is the nodal. Just now we start at the nodal for a while. So this one you can refer to the online material. Nodal analysis. This is just explain only. Make sure you can score 100%. And then the question 4, mesh analysis. I think this is possible. Right? This is the voltage dependent source. This voltage source depends on this voltage. And then don't do B. Okay, B for the next tutorial. Okay, guys, that's all for today. I'll see you on the next tutorial. Okay. Okay, bye-bye. Any question you want to ask before I end this session?
Yeah, sorry, I have some questions. Actually.
Okay.
So during our answering on the Word document, right? So
put your answer.
Might redraw back the circuits using normal drawing tools, or we can just use this any any other sites that can draw the circuits and then just paste pictures, something like that.
To draw the circuit, you can use any method you have. any method
Okay.
you know, and then just circuit you can use the any graphic to draw it and then import to the Word document.
Mm-hmm.
But for your answer, you need to type into the Word document.
Okay.
Okay, for your answer, you need to type. You cannot just draw like this, okay? Because
Yeah.
based on policy, you need to type it in. Cannot use a handwritten one. Handwritten, not accepted. Okay.
All right. So only for the circuit, so we can use.
Yeah,
that.
circuit you can draw it, of course. Yeah, circuit you can draw it.
Okay. Thank you.
Right. Okay.
Right.
But for your final exam, you can write handwritten everything. For final exam is different. Final exam, because you have limited time, 2 hours, it means you need to use the fastest way to answer the question. Is use a handwritten assignment. Okay.
Right.
For assignment 1 and 2, you need to type it in. Okay, guys, is there any other question you want to ask? Okay. But we still have tutorial 2. If you can if you want to keep it until tutorial 2 to ask me, it's okay. After tutorial 2, you still have about 7 days to complete it and submit your assignment. Okay, so for now, I'll say goodbye to you. Have a nice day. Okay, bye-bye.